This is section 7.3, number 10. So we're still in this cylindrical shell method. It says, find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. And we have all these curves, and we're revolving it about that line. So the first thing we should do is try to sketch these curves. We already know what y equals x squared looks like. It's the parabola. And then it's bounded by these two vertical lines, x equals 1 and x equals 5. So let's see if we can sketch this. X equals 1 would be a vertical line, and x equals 5 would be a vertical line. And you can imagine this parabola going up like that, but it's being bounded by x equals 1 and x equals 5. And y equals 0 is this x-axis right there. So that's the region. Now this is being revolved about the line, rotated about the line x equals 7, which is this one right here. So let's see if we can sketch what this would look like. If I drew its mirror image about that line, it would look something like that. It's kind of rotating around that one. This is an excellent example where shell method would be much, much, much easier than washer method. Here, my cylindrical shell should look something like this. I'll pick some value of x, and I'll draw a line, and I'll draw the same line right here, and I'll draw this cylindrical shell right there. And it's got just a little bit of thickness, and it makes that little cylindrical shell right there. And I need to figure out whether I'm integrating with respect to x or y, and what the radius and the height are. Well, this little distance right here is a horizontal distance, so here I'm going to integrate with respect to x. If I were revolving around a horizontal line, this little thickness would be a dy, and I'd integrate with respect to y. But here I'm revolving around a vertical line, like the y-axis, or x equals 7, so I have a dx. So the volume should be the integral of the radius times the height with respect to x. So I need the radius and the height. And then the constant I should have is 2 pi. So 2 pi radius height times dx. Now this one's kind of nice because we're told x is going from 1 to 5, so we already have the limits of integration. X starts at 1 and goes to 5. Now the height is this distance right here. This is the height. Now that is definitely a y distance. If x is right here, the height of that is x squared. That's y equals x squared. That's the height to that parabola. So that one's not too hard. The radius is a little bit more challenging. This distance right here is x from there to there. But the radius is this distance. Well, if this total distance is 7, then this distance of the radius would be 7 minus x, right? The total distance of 7 minus that x. So the radius should be 7 minus x. The most challenging part of these problems is usually the setup. A good picture can help you a long way, but here we figured out to integrate with respect to x. We figured out the radius was 7 minus x, and the height was x squared. So now let's see if we can plug this in and get our answer. I'll take that 2 pi out, the integral from 1 to 5, and I'll multiply this 7 minus x times x squared. So 7 times x squared is 7x squared, and negative x times x squared is negative x cubed. Okay, so this would be 2 pi. Let's see, the integral of 7x squared would be 7 over 3x cubed. The integral of x cubed would be 1/4, x to the 4th. And here I'm going to evaluate from 1 to 5. So it's going to look a little, I'll have to think about these limits of integration a little bit. They're not something really easy like 0. So if I plug in a 5, I'll have 7/3, 5 cubed, minus 1/4, 5 to the 4th. And if I plug in a 1, I'll have 7 cubes times 7 thirds times 1 cubed minus 1/4 times 1 to the 4th. Okay, so let's see what this ends up being. This is 2 pi. Okay, I'll probably use a calculator for some of these numbers. 5 cubed is 125 times 7 is 875. So this would be 875 over 3. 5 to the 4th is 625. So it'd be 625 over 4. And then let's see what else I have. I've got minus 7 thirds. So minus 7 thirds minus a negative, so that'd be plus 1/4. Now if you want to leave the answer like this and plug it into your calculator or WebWork, that's fine. Some of these do simplify a little bit nicer, so let's see what we can get. 875 minus 7 would be 868 over 3. Once again, that was 875 minus 7 will give me 868 over 3, combining those thirds. If I do 625 minus 1, I'll get 624 over 4. And we'll see if these numbers turn into something nice. 868 divided by 3 doesn't turn into anything great. 624 divided by 4, that turns into 156. So let's go ahead and just turn these all into thirds. So 156 is the same as this number. If I multiply it by 3, I get 468. So this would be 2 pi, and I'd have 868 minus 468 over 3. And let's see if I can figure out what this is. 868 minus 468. Probably could do that in your head. It's 400. So it looks like this is 2 pi times 400 over 3. Or to make it look a little bit nicer, this would be 800 pi over 3. That's a little simplified version to plug into WebWork.